Welcome back to math. These are the practice problems for section 14 on triangles and rectangles. Problem 1 says determine whether the following sets of angles represent an acute triangle, a right triangle, or obtuse triangle. So we're describing the triangles based on their angles. This one has an angle that's exactly 90 degrees, so that would represent a right triangle. This one has an angle that's greater than 120 degrees, so it's obtuse. And this one has all the angles the same and all less than 90 degrees, so it's acute. Problem number 2. Determine whether the following sets of side lengths represent an equilateral, isosceles, or scalene triangle. So we're describing the triangles based on their side lengths. This one has two side lengths that are the same, and that's the definition of isosceles. These are all different, so that would be scalene. And these are all the same, or equilateral. Problem 3 says, given that these two triangles are similar, find the value of x. So we're told that they're similar, so that they have the same angles but proportional sides. So let's set up our proportion. Here we know, let's call it the side, the here, and the base. In this triangle that's 2 and 6, and here that's 3, and the base is what we don't know. So we can cross multiply. 18 equals 2x. Divide both sides by 2, and x equals 9. So this base is 9. Problem 4 just says find x. So here's a x. We know this is a right triangle because of this square that's drawn into that angle. So we know that we can use the Pythagorean theorem. A squared plus b squared equals c squared. C squared always has to be the hypotenuse. That's the long side that's across from the right angle. So that will be 15. This can be either a or b. So 9 squared is 81. That's 9 times 9. Plus b squared equals 225. That's 15 times 15. That means that b squared equals 144. I've subtracted 81 from both sides. And now if we take the square root of both sides, the square root of 144 is 12. That's because 12 times 12 equals 144. Whoop, that shouldn't have a squared sign on it. So this is b equals 12. In problem number 5, we'd like to find the measure of angle x. That's this angle here. We know that in a triangle, all the angles add up to 180. We know the measurement of these two. This one, because we're told that this little square box says that that's 90 degrees. And we know that this, we're told, is 60. So the remainder, x, added on together must equal 180. So this is 150 plus x equals 180. Subtract 150 from both sides, and x equals 30. So this is a 30-degree angle. Problem 6. Find the area of the following triangle. Well, the formula is 1/2 times the base times its height. This looks like it's the base, 12, and the height is measured outside, but it's 3. So 1/2 times 12 would be 6. 6 times 3 is 18. We have to label this because we're finding the area as square feet, because we're given the foot abbreviation there. Problem 7. Joe wants to fence his garden, which is 50 feet long and 20 feet wide. Let's make a little picture here. It sounds like a rectangle. 50 feet long and 20 feet wide. How many area of fencing does he need to buy? All right, so that means the outside is going to get the fence. So we need to find the perimeter. That's going to be 50 plus 50 for both sides, and 20 plus 20 for these sides. That's 140, and these are in feet, so he needs to buy 140 feet. Problem 8. What is the area of the non-shaded part of this shape? Well, the non-shaded part is this area. So what we need to do is find the area of the whole thing and subtract this triangle, and that will leave us with the non-shaded part. All right, let's start with the rectangle, and that area is base times height. The base, this is 3 inches and this is 3 inches, so that means the base is a total of 6 times the height, which is 4. That's 24. Now the triangle. That's 1/2 of its base times height. So 1/2, its base is 3. Its height is 4, because remember, this is a rectangle. Both the opposite sides are equal length. So that's 4. So that would be 6. So the rectangle minus the triangle is 24 minus 6. That's 18. And we're doing area, so we have to do square. And in this case, it's inches. In problem 9, we want to find the total area of a room with this odd shape. There's a 14-foot dining room connected to a living room with these dimensions. This is 12, and this part of it is 18. So we need to find the area of this rectangle and add it on to the area of this square. So let's do the rectangle first. Its area is base times height. The base is 18 plus this 14. So the whole base is 32. The height of the rectangle is this. That's 12. And 32 times 12 is 384. Now let's do the square part. And of course, we know that this is 14, so this must also be 14. We're told it's a square, so its base times height is 14 times 14. And 14 times 14 is 196. Now we just add those two together, and we get 580. We need to label that as square feet. Problem 10. An isosceles right triangle, that's this, is connected to a square with a side of 5 meters. What's the area of the resulting shape? Well, once again, we have to find the two and add them together. So let's do the square first. It's base times height. We know that it has the same measurement for its base and its height, so that's 5 times 5, or 25. The triangle part is 1/2 its base times height. Its base, well, we don't know too much about it from the description, but we are told that this is an isosceles right triangle. That must mean that this side and this side are the same. We know this side is 5 because this is a square. So it's 5 for its base and 5 for its height. That's 1/2 of 25, which is 12.5. And again, we have to add those two together. Add together 25 and 12.5, and we get 37.5 square meters.